Good morning. Today we are going to discuss amplitude shift keying, ASK, amplitude shift keying. Right. Now, first, what is the use of this ASK? I said yesterday only, last class only. For every or any digital modulation technique is used to convert a digital signal to analog signal. Every digital modulation technique is used to convert digital to analog, right? Now we are going to discuss ASK, amplitude shift keying. The definition of ASK is the amplitude of the carrier signal is varied according to input binary data. The amplitude of the carrier signal is varied according to input binary data. That is a definition of ASK. Now, in this case, I am using in M-ray ASK, M-array modulation. Here, M is equal to 2 power n. So, in this case, n is equal to 1. So, that M is equal to, you will get 2 levels. That is bit 1 and bit 0, 2 levels, right? And it is also called as BASK, binary amplitude shift keying, BASK, binary amplitude shift keying. Now the generation of ASK. Of ASK, generation of ASK. Now if you see the block diagram of ASK, the block diagram of ASK consists input binary sequence. Input binary sequence, we can take it as 1 1 0 1 0. This is, let us take, this is my input binary sequence, and it is passing through unipolar NRZ, and output of unipolar NRZ is multiplied with product modulator with high frequency carrier, local oscillator carrier. The carrier signal is A cos 2 pi FCT, and output of product modulator we will get BASK. In BASK only two voltage levels, that is bit 1 or bit 0, or symbol 1 or symbol 0, and in this case for n is equal to 1, the symbol rate or symbol duration is equal to bit duration. Symbol duration T is equal to bit duration, right? Now this is a block diagram. Let us see here. Bit 1, here I am writing bit unipolar NRZ BASK equation or ASK equation. Now for bit 1 in unipolar NRZ, bit 1 is mapped to plus A volts. Let us call it as plus A is equal to plus 1 volt. The equation, the plus 1 is multiplied with local oscillator carrier A cos 2 pi FCT. So that S of t equation is A cos 2 pi FCT. For bit 0, 0 is mapped to 0 volts. So that S of t equation is 0. For bit 1 in unipolar NRZ, 1 is mapped to plus A volts. The ASK signal, modulated signal is A cos 2 pi FCT. For bit 0, 0 is mapped to 0 voltage, S of t is equal to 0, right? Now the waveform representation of BASK binary sequence is S11010. This is my binary sequence BL, and here unipolar NRZ, unipolar NRZ. So in this case, symbol duration T is equal to TB. First case, bit 1 is mapped to, just now I said bit 1 is mapped to plus 1 volt, bit 0 is mapped to 0 volts. So the voltage level is plus 1 volt, right? Now bit 1 is mapped to plus 1 volt, and again second TB duration is also bit 1, it is mapped to plus 1 volt, and bit 0 is mapped to 0 volts, and after TB duration again bit 1 is mapped to plus 1 volt. After 4 TB duration, that is bit 0 is mapped to 0 duration. This is unipolar NRZ output, right? This unipolar NRZ output is multiplied with high frequency carrier signal, right? So carrier signal C of T. Now this is my high frequency carrier signal C of T, high frequency carrier signal C of T. Now ASK signal, BASK signal. So here just now I said when bit 1 output of S of T is A cos 2 pi FCT, same signal, right? When bit 0 output of S of T is 0, right? Here in this case we find two ones. So up to this point I am getting, this is amplitude is plus A, here minus A of the carrier signal amplitude is A, right? For up to T2 TB duration I am getting same signal, right? Same signal, right? After 2 TB duration the bit 0 is transmitted, so that output is 0. After 3 TB duration again signal S of T will be AC cos 2 pi FCT, again output is 0. This is modulated signal of BASK, right? Now we can see the bandwidth calculation of BASK, right? Bandwidth calculation of BASK. BASK bandwidth calculation. We know that bit TB will be this one, 0 to TB, amplitude is 1. By shifting towards left, this one becomes, so it becomes TB by 2, here minus TB by 2. Fourier transform of this one is, this is time domain T, here TB by 2 minus amplitude is 1. Okay, Fourier transform of this one is, we will get sinc function. I am concentrating only on major lobe. This is my sinc signal, it is my sinc signal. Here this point is 1 by TB, this point is minus 1 by TB. So almost 99% of power consumes only major lobe. So that I am writing here simply, this is the Fourier transform of this one. It is 1 by TB minus 1 by TB frequency F, right? Now it is this one is multiplied with the carrier signal a cos 2 pi fct. Fourier transform of carrier signal, we know that one will be at fc, its amplitude is a by 2, another one will be at minus fc, its amplitude is a by 2. This is c of f. Now by multiplication of these two, we will get a signal like fc. This misses signal is shifted around with fc plus fc, here fc minus 1 by tb. Similarly, negative side also minus fc, it will shift around with minus fc plus 1 by tb minus fc minus 1 by tb. Now if you calculate bandwidth of this one is highest frequency component minus lowest frequency, fc plus 1 by tb minus fc plus 1 by tb. So here the bandwidth of ask is 2 by tb, and bit rate of this one is bit rate or b is equal to nfs. So this is also called as, this is small n by ts. Ts is a symbol rate. So in this case ts is equal to tb for bask, right, and n, small n is equal to 1. So bit rate of bask is equal to n by ts, that n by tb, that is 1 by tb. Bit rate is 1 by tb. Now we can see the detection of ask. Detection of ask is two methods. See the detection of ask. Detection of ask is a two methods. One is coherent detection, another one is non-coherent detection, right? What is the difference between coherent detection and non-coherent detection? I already said. The coherent means synchronous between transmitter and receiver. Synchronous between transmitter and receiver. Whatever the carrier signal you are used at the transmitter, the same carrier signal should be used at the receiver side. That is called as a synchronous between transmitter and receiver. In non-coherent, so non-coherent, even though if you use carrier signal in the transmitter, but need not to use the carrier signal at the receiver, that is called non-coherent. First I am going to explain coherent ASK or coherent BASK. The block diagram of coherent BASK, it consisting of modulated signal ASK, modulated signal S of t is multiplied with the product detector with high frequency carrier signal, that is local oscillator, and it is output of product detector passing through low pass filter, and output of the low pass filter passing through decision device, where decision device it consisting of internal level, that is V threshold voltage is equal to 0, and output we will get demodulated signal. Now if you see here, the operation of this coherent is two cases. One is no phase in the carrier signal. So in this carrier signal there is a phase pi is equal to 0. So pi is equal to 0. If you write here cos 2 pi fct plus pi, so here pi is equal to 0, right? For example, in S of t, for bit 1 equation is, S of t equation is a cos 2 pi fct, right? Now for this case, product detector output is S of t is multiplied with local oscillator carrier. So here a cos 2 pi fct is multiplied with local oscillator carrier a cos 2 pi fct, it becomes a square cos square 2 pi fct. So this can be written as a square by 2 cos cos 1 plus cos 2 pi 2 fct, right. So it becomes a square by 2 plus a square by 2 cos 2 pi 2 fct. So by passing through low pass filter, this signal is passing through low pass filter, it doesn't allow this 2 pi 2 fc because of higher frequency component. The second component is not allowed by low pass filter, therefore low pass filter output is a square by 2, right. Output of the low pass filter is given to decision device, therefore the decision device, it compares this low pass filter output with internal threshold level. So a square by 2 is greater than 0, so output of the decision device will produce the output in the favor of bit 1. See here, bit 1 we are transmitted, the input bit 1 we are transmitted, the demodulated signal it produces bit 1, right. Now second case, pace is present when pi is present, right. So S of t equation is a cos 2 pi fct is my S of t, and local oscillator carrier signal is a cos 2 pi fct plus pi, right. The product here, the product detector output is a square cos 2 pi fct into cos 2 pi fct plus pi, right. The resultant, if you see here, cos a cos b is equal to cos a plus b plus cos a minus b by 2. So I am writing here the same equation is product detector output is equal to a square by 2 cos a plus b, that is 2 pi fc plus fc cos 2 pi fc plus fct 2 fct plus pi plus cos of a minus b pi. This is my equation. This is cos a plus b, 2 pi fct plus 2 pi fct, it becomes 2 pi 2 fct plus pi. And second one, a minus b, this one minus this one, you will get cos pi, right. So this signal is passing through low pass filter. So because of this high frequency term, this signal is not passed through low pass filter. So output of low pass filter is a square by 2 cos pi, right. A square by 2 cos pi, right. In this case, now see here, in this case, if pi is equal to 0, output of the low pass filter is a square by 2, pi is not equal to 0, that is for example pi by 2, 90 degrees. So pi is equal to 90 degrees, output of the low pass filter is 0, right. For this case, the decision device will produce a square by 2 is greater than 0, it produces bit 1. But in this case it is unable to produce, it produces bit 0, yes or no. So the final one is In coherent ASK, the pace also should be synchronized. Important, pace should be synchronized. Should be synchronized. Right? Now, and here in this case, for next one, if bit is 0, s of t equation is 0, right? Bit is 0, s of t equation is 0, right? Here product detector output is 0 multiplied with a cos 2 pi fct. Here you will get 0, 0 compared with 0, the decision device produce output is bit 0. This is the operation of coherent ASK. Now I am going to explain non-coherent version of ASK. In non-coherent version of ASK, this is modulated signal S of t. This modulated signal S of t is passed through envelope detector and followed by the decision device. We know the operation of envelope detector. Envelope detector will give the envelope of input signal. So output of the envelope detector, it produce only amplitude levels, right? For bit 1, the S of t equation is a cos 2 pi fct, right? A cos 2 pi fct. So for this signal, the envelope detector will produce envelope of input signal. So what is the envelope is here? Whatever the envelope you will get, that is A, right? Now this A is greater than threshold voltage 0, so output of the decision device, it produce the favor of bit 1. If S of t is equal to 0, envelope detector doesn't produce any output, so that output of the envelope detector output is 0. So that decision device output is also produced in favor of bit 0. This is the non-coherent version of ASK. Now we can see the advantages both coherent version as well as non-coherent version. Coherent and non-coherent, right? Now yesterday only I said this is more efficient, advantages, more efficient and costly, right? And costly and another one, for this case, this costly is we can written as a disadvantage. This is advantage. Here in this case, it is low cost, advantage. Another disadvantage in this one, should be synchronized. Should be, that is pace should be synchronized. Pace should be synchronized. Right? Now applications is, it is used for broadcasting purpose. Yes, broadcasting. Basically this PASK or BASK, it is used for optical fiber communication. Optical fiber communication. Right? This is the advantages of BASK. Now today your assignment is define ASK, modulation and demodulation of ASK. Third question third is bandwidth and spectrum, bandwidth and bit rate of ASK here with waveforms. Fourth one, applications, advantages and disadvantages. Thank you.